Let's go ahead and talk about how we find the maximum amount of consumption by looking at this equation that shows consumption when we are in our steady state. So what we've designed so far in class is we said consumption in the steady state is going to be equal y minus n plus delta times k. And the reason why is this is my income, and this is going to be my investment, which equals savings, and this is the amount of investment in steady state. So it's important to understand that this right here, this is the amount of investment keeping our model in steady state. So that's why, right? And then also, right, we know that savings equals investment when we're in equilibrium. So when we're in equilibrium, we're in steady state, this is going to be the amount of consumption that's present. Now we know output, right? We said output's going to be equal to A times F of K, which is our production function. So we can say that consumption, or per worker production function, pardon me, we can say that C is equal to A F of K minus our N plus delta times K. So this is going to be our level of consumption. And what we're going to do is we're going to take it and we're going to graph it. I'm going to move these over here a little bit to give us a little bit of room. And what we can do here is we're going to stack these graphs. So on the bottom, I'm going to look at consumption. And on the top, I'm going to take Y, but then we're also going to look at the N plus delta times K. So what I'm doing here is I'm looking at both of these separately, and then we'll take the difference between those two functions. So what are we looking at here on the horizontal axis? We're going to measure both of these with per worker level of capital, so our capital to labor ratio. So the reason why we can stack these this way is because our horizontal axes are going to be exactly the same. So let's do each part of this. So remember, y is our per worker production function. And our per worker production function, right, is that A times F of K. And we have this increasing at a decreasing rate because we have diminishing marginal returns to capital. All right, so that's why we have that there. And we know the second part of this equation is just going to be a straight line with the slope equal to n plus delta. This is n plus delta times k. So as k goes up by 1 unit, this goes up by n plus delta units. What does this tell us? Well, this tells us that, if I know that it's the difference between these two, we know that there's a point right here where it's going to be equal to 0 because they're equal to each other. And then there becomes a point eventually right here, so this level of capital, where we've made so much capital, right? We've made so much capital that all of our production is going towards replacing the depreciated capital and adding it for individuals, right? That's what that n plus delta is. And so we have that other value of k right here. This is where it's going to be equal to 0. So these are important points because we say, hey, we can't produce so much capital. We can't have so many sewing machines in our factory that we don't buy anything else because then we have no consumption. There's got to be a point somewhere here right in the middle. In fact, it's going to be where these two slopes are exactly the same. There's got to be some point right there. This level of capital is going to provide us with some maximized level of consumption. So notice that the consumption is going to start going up. It's going to hit that. That's going to be the top, and then it's going to come down. This right here is going to be my level of consumption. So this maximum level of consumption, that's what we call C star, right? Sometimes you'll see a little G on the bottom here, and that's going to be the golden rule of capital. So this right here is showing us that there's a point where consumption is maximized in the steady state, and that we can't just, there's going to come a point where if we continue to produce more and more capital, we're actually going to start seeing our consumption, our ability to consume, decrease. And that reason all comes from up here, right? This, which I keep underlining, that's the amount of investment that's needed to keep us in steady state. And the reason why is because some of that has to go towards that N value, which is our increase in population growth. So I have to give the new people capital, and then I also have to replace the depreciated capital. So if I make a bunch of capital, right, if I'm way up here, then that's going to outweigh my production and my consumption is going to start to fall. So we have this level of capital that gives us a maximum amount of consumption, which is our golden rule of consumption.